turning moment diagram for a multi-cylinder engine has been drawn on a scale of 1 mm equal to 500 Newton meter torque and 1 mm equal to 6 degree of crank displacement. The interrupted area of mean output torque curve and mean resistance line taken in order from the end in square meter or -30, 410, -280, +320 and so on. It clearly shows that this is the turning moment diagram of steam engine. When the engine is running at 800 rpm, n equal to 800 rpm. From that we can find omega 2 pi n by 60, you will get 83.8 radian per second. The engine has a stroke of 300 mm and the fluctuation of speed not to exceed plus or minus 2% of mean speed. So fluctuation of speed omega 1 minus omega 2 equal to plus or minus 2% means 0.02 of mean speed. So plus 0.02 minus 0.02, that I can take it as 0.04. Then move this omega here. So omega 1 minus omega 2 divided by omega is nothing but CS. So CS equal to 0.04. We need to find out the diameter and the cross section of the flywheel rim, breadth and thickness. The density of material 7,200 kilogram per meter cube. The width of the rim is 5 times the thickness of flywheel. So breadth equal to 5 times the thickness. So these are all the given data. So with this data, and then one more data, centrifugal stress, shear stress equal to 7 megapascal, 7 into 10 power 6 Newton per meter square. With this detail, we need to find diameter, breadth and thickness. Let us draw the turning moment diagram first for this specification. So this is the turning moment diagram for this specification. Energy at point A equal to E. Energy at point B equal to energy at point A minus 30. Because of this downward direction, this should be minus. Then energy at C equal to energy at B. So what is energy at B? E minus 30. We will take that value as it is. Then with that value, energy at B, we need to add 410. So add 410. So this should be E plus 380. Then energy at D. What is energy at D? Energy at C minus 280. Energy at C, E plus 380. Then minus 280. You will get E plus 100. Then what is the energy at E? E. Energy at E equal to energy at D plus 320. Already energy at E plus 420 minus 330. Why it is minus 330? Because of this downward direction. So downward minus, upward plus. You will get E plus 90. Similarly, if you find energy at G, H, K and L, you will get this value: E plus 340, E minus 20, E plus 260 and E. Just check the starting point and the end point. You will get same E. It shows that you have done the calculation properly. So this is the variation of energy at different point. Here we have to take the maximum energy and minimum energy. So this is the maximum energy. Similarly, you have to find the minimum energy. From that we can calculate del E. Few parameters are already given. With that parameters, we will try to find diameter. We know that tau shear stress equal to rho V square. Tau value given 7 into 10 power 6. Then density also given 7200. Velocity unknown. Just rearrange this term, you will get velocity. So velocity equal to 31.2 meter per second. We know that V is equal to pi dn by 60. Again n value given 800. So now substitute all the parameter. 31.2 equal to pi d 800 divided by 60. here d unknown, then we can find d value. So d equal to 0.745 meter. So this is how you can find the diameter of the flywheel. Then few other parameters also given. Area equal to b into d. Again, breadth equal to 5 times of thickness, so 5t into t. This is also given data. So area is nothing but 5t square. Then the scale factor 1 mm square equal to 500 into pi by 30, 6 degree, 5 by 30. When you cancel this, you will get 52.37 Newton meter. So 1 mm square equal to 52.37 Newton meter. Now we have already calculated energy at different level. What we need is del E. Del E equal to maximum energy minus minimum energy. Refer the previous slide where maximum energy E plus 420, minimum energy E minus 30. Let me go back to previous slide to show you the maximum energy. E plus 420, then E minus 30. This is the minimum. So now coming back to the slide. So when you subtract these two terms, you will get 450 multiplied by this scale factor of 52.37. You will get 23,566 Newton meter. That is the value of del E. Now there is a formula for del E. Del E equal to mv squared cs. Why we are using this formula particularly? Because we already know the value of v. So m unknown, velocity known, cs known, del E value available here. When you substitute, you can find mass of 604 kg. So with this we will move on to mass equal to density into volume. Again, density into volume pi dA. If you see the shape of flywheel, it looks like this. You just cut this portion, you can see a rectangle, and this is the thickness, this is the breadth. So take this portion and the circumference of the circle pi d. Multiplying these three parameters will give you t in b into dA. So pi dA is nothing but volume of flywheel. So pi, diameter 0.745 will be here, then area 5t squared into 7200. All are known value except thickness. Now we can find thickness by rearranging all the terms. Thickness equal to 0.085 meter. If you know thickness, you can easily find breadth, because breadth equal to 5 times of thickness. So 5 into 0.085 meter, you will get 0.425 meter. So this is the value of breadth. So this is how you can find breadth, thickness and diameter of the given specification of flywheel using turning moment diagram. Don't forget to post your questions in the comment box. You can also mention the topics which you expect from my channel. Subscribe my channel and like my video to support my video lecture.